Now, learning objective C wants us to factor and solve the quadratics. So we're going to continue in our factoring. We just have to go that extra step this time. Once we have the factors, set them equal to 0 and solve. So let's practice some more. Take our trinomial here, break it into two binomials. My 4x squared has to go at the beginning. So again, the x squared is easy, x and x. Now this 4 can be tricky. It's either a combination of 4 and 1, or it's 2 and 2. And I just don't know which one it is. I feel like trying the 4 and 1. Okay. Now I need factors of negative or positive 2, so I like that. That's 2 and 1. They have to go here and here. So when I check my middle term, I get a 6x. It looks like if I do plus 2 here and plus 1 here, I will get a 2x and 4x, which adds to 6x, so I got it. Great. Now don't forget, set it equal to 0. So that's factored, but they also said now solve it. So to solve it, remember, take the two factors, set them equal to 0, and solve. So we're going to set these equal to 0 and solve. The one on the left here, I'm going to subtract 2. So I have 4x equals negative 2, divide by 4, x is equal to negative 1/2. This one over here, just subtract 1 from both sides. I'll get x is equal to negative 1, and we have our two answers. Now the other thing you may have thought is when you first saw this problem, when we did it in Learning Objective A, you can actually factor out a common constant. And I want to show you real quickly how that can still work. If I take this current problem here, let's take this and instead of factoring right away into two binomials, let's notice a 4, a 6, and a 2 both have a 2 in common, which means I'm going to factor the 2 out. So if I factor the 2 out of here, 4 divided by 2 is 2x squared, 6 divided by 2 is 3x, and 2 divided by 2 is 1. Do set it equal to 0. I can actually solve it this way and still get the same answer. What I next need to do is to factor this trinomial. Don't lose your 2 that's sitting there. If we factor this, again, factors of 2x squared are just going to be broken up into 2x and an x. The only way to get a positive 1 is plus 1 and plus 1. So if you do this, you're going to notice 1x and 2x does equal to 3x, so we're correct. Now, to solve this one, the only adjustment you would do is you would want to take all three pieces. So you need to take this and set it equal to 0, this equal to 0, and this equal to 0. So you would say 2 equals 0, and you set it up as an equation. This right here makes no sense. So 2 equals 0 crosses out and can't even become an answer. The next one though, 2x plus 1 equal to 0. When we solve that, we're going to just subtract 1, divide by 2. So we're going to get x equals negative 1/2, which is what we already got up here. For this one here, when we set that equal to, we're going to have x plus 1 equals 0. When you solve that, you're going to get x equals negative 1. And when you do that, you're going to notice this is the same answer as that. You could factor either one of these two ways. You can either do how we originally did the problem and not factor out a common constant, or you can recognize if it's easier for you to try to factor out a common constant and make it just a better approach for doing it. Okay, let's look at another one. Again, I can tell I have to solve because it's equal to 0. So I'm going to take 3x squared, x and x for sure. 3 is only 3 and 1, so that's nice. Then I have to put 15 here and here. So when I multiply these two, I get an 18x. 15 has a couple combinations. 5 and 3 or 15 and 1 are going to work. And if you take a look at it, I think I see it. Plus 15 plus 1. Check it. This would be 15x, 3x, which adds to 18x, so we've got that. Now let's take our two factors that we found, set them equal to 0, subtract 15, And divide by 3 on both sides. So this one will be x equals negative 5. This guy over here, just subtract the 1. X equals negative 1. So those are our two answers this time. Similar with this problem up here, we may have wanted to factor out a common constant beforehand. Let me just show you that approach real quickly. The common number that 3, 18, and 15 have is the 3. So if we factor out that 3, what we're going to get is an x squared, a 6x, and then a 5 equals 0. Now what we can continue to do here is we can come on back and we can actually factor this out. Don't lose the 3. So when we factor this out, the x squared just becomes x and x. Factors of 5 plus 1. These two have to multiply to be 6x, which they do. Then to solve it, you take each little piece, all 3 of these, and set them equal to 0. Again, 3 equals to 0 makes no sense because it's not true. X plus 5 equal to 0 becomes x equals negative 5, which we already have up here. X plus 1 equals a 0 is going to become x equals negative 1, which we noticed we have up here too. Again, either approach works. You can either factor out a common constant to make this factoring overall easier, or you can keep it and just factor it as normal. This works for factoring and solving. If you were asked to factor completely and not solve, then you do need to pull out the common constant. Let's look at one more, and this is actually pretty involved. We just have to kind of see how lucky we can get with this. So lots of different choices to try. I'm going to take the 8x squared, do x and x, and I'm going to try 4 and 2. I don't know if it's 4 and 2 or 8 and 1, but I'm going with that. Factors of 12, there's a lot. So it's either 12 and 1, 6 and 2, or 4 and 3. Keep in mind, I don't even know if 4 and 2 are right. It might be 8 and 1, so I'm hoping I'm at least kind of right. And I'm going to put the factors of 12 here and here, so we get this and this come back to a 28. And I'm just going to kind of eyeball it, and I think we made the right choice. I think this one's going to be the 6 and 2 combo. If I put the plus 2 here and the plus 6 here, look at this. 2 times 2 is 4x. 4x times 6 is 24x. Gives me 28x. Great. So let's set those two equal to 0 and solve. Here I'll get x equals, 4x equals negative 2. I'm going to divide by 4, so x equals negative 2 over 4. And that'll be a negative 1/2. Here I'm going to subtract the 6, so x equals negative 6. Divide by 2, negative 6 over 2. So x will be negative 3. Now for this one, there actually was another combination that would work. I think there's almost even 3 for this, but let's see if we can find a different one that we could have gotten for factors, because all those factors would still come back to the same 2 answers that we had. So let's just set this up here. Kind of do a little block it off. Is there another combination that would have worked? I'm going to try 8 and 1 for a second. And why don't we try, looks like 3 and 4 would work with this. If I did a plus 4 plus 3, let me just double check, that's 4, that's 24, that would be 28. Now look what happens, you guys, when we solve this, we're going to get the same 2 answers that we had before. So when you factor and solve, it's different. I'm going to subtract the 4, divide by 8, that will give me negative 1/2. Then this other guy, when you solve it, you're going to get the negative 3. So we're going to get the same answers. So on this one, there might be multiple ways to factor it, but because we're solving, it doesn't matter which way you chose. You still will get the same solutions in the final outcome.